Okay, so here we come to part 2 of the basic maths about differentiation, related rates, and integration. So it's a part of pre-calculus that we are going to use in physics, okay? So the definition of differentiation is to find the rate of change, okay? Such as for dy by dx. So if I have the function that has the value y, and I want to find the rate of change, like how fast change, okay? Is I just try to draw a tangent line, and the slope of the tangent line will be the differentiation and the rate of change at that point, okay? So if I try to see the rate of change at the other point, such as at this point, I can also draw the tangent line, and we can also calculate the rate of change at any other points. For example, if the function is decreasing, okay, if the value function is going down, the slope of the tangent becomes negative. Okay, but if the function is going up, the slope of the tangent is positive. But if the function is at the turning point, okay, the slope of the function is 0. So that means there's no change of the function value at the moment. Okay, so to be a little bit more in the algebraic examples, okay? So if we try to differentiate some functions in simple forms, okay? For example, if we start with differentiating a constant, okay? What we come up with differentiation is 0, okay? Because the constant means no change, okay? When it means no change, we try to find the rate of change, okay? It should give you 0 automatically. For example, you try to diff 10, you get 0. You try to get diff 5 with respect to y, you get 0. Or you try to diff 1 million, okay? You diff 1 million with respect to z, you just get 0 all the time, okay? Then if you come up with some with some polynomial, okay, with a term in the polynomial, if you have the x power n and you try to differentiate x power n, what you come up with is you bring down the n, okay, 2 times with x and power by n minus 1, okay? So for example, if you have x to the 3 and you try to differentiate x to the 3, you come up with 3 times x, and the power is reduced to 2. And if you try to diff x times x power 5, you just come up with 5x to the 4, okay? And if you try to diff like 1 over x to the 6, something like this, okay? Here, what you can do is you can write 1 over x to the 6 as x to the minus 6, okay? And when you diff this x to the minus 6, the minus 6 will come over here, and then what left for your x term is x to the minus 7, which is minus 6 over x to the 7, okay? Then if you find that your function is timed by a constant, for example, if I come up with 3x to the 5 and try to differentiate this, so the constant will not be involved in differentiation. So we bring 3 over here and we try to diff x to the 5. Okay, so diff x to the 5 is 5x to the 4. When you times it by constant 3, you get 15x to the 4. And when you have 2 functions added up together, you can distribute differentiation for each term, and then you can just add them up. For example, 3x to the 3 plus 2x to the 4, and you want to differentiate this polynomial, okay? So you work out the first term. The first term will be, so we bring 3 down, and we have 9. So 3 times 3 is 9, and this exponent is exponent is reduced to x to the 2, and plus 2x to the 4. We bring 4 down and times with 2, you get 8, and it is x to the 3. Okay, so let's work out more examples. Okay, so you have y equal to x, and you do the dy by dx, which is dx by dx, and x here is actually 1, x to the 1, yeah, x powered by 1, and I bring 1 down, and the x here become x to the 0, and x to the 0 is 1. So you have 1 for this. Okay, and y, and when you diff 3x, okay, it is 3 times diff x, and diff x from the last one is from the last example was 1, so we just come up with 3. Okay, so next time if you see something like, if you try to diff, for example, 10x, okay, you can just come up with 10. Okay, then for x squared, okay, so dy by dx, then it would be 2x to the 1, or it would be just 2x. Okay, and then if you then have a function of the other variables such as t, or it could be like time, for example, and you want to differentiate y with time, okay, the rate of change with time. So we work on these terms like term by term. We work on the diff of 1 first, okay. So diff of 1, or diff a constant, will give you 0, okay. And diff of 5 minus 5t, you get you minus 5. And diff of t squared will give you 2t. Okay. Then again, so where it come from? So the first term, it is the diff of a constant, so that you get 0. The second term, it is minus 5 and times by diff of itself. So diff t by t is 1, so it's minus 5. And the last term, it is d by dt, or diff of t squared. You get 2t. So you add them up together, and your answer will be 2t minus 5. Okay. So for number 9, for example, what you can do, one way to do it is to expand this polynomial into this form. Okay, so times the t into each term will give you t to the 3 and minus t squared. So you do dx by dt. Okay, it will be diff t power 3, and it would be minus 3 and diff t squared. Okay, and it would give you 3 t squared and minus 3 times by 2t. Okay, so your final answer will be 3t squared minus 16. Okay, and some other samples. Okay, so like if we have the square root of x, okay, so the square root of x can be written in terms of x to the half. Okay, so when I do dy by dx, okay, so x to the half, okay, is I bring down the power of half to the front, so it's half, and what left here is half and minus 1, okay, which is half times by x to the minus 1 over 2, and that can be written in terms of 1 over 2 over square root x. Okay, chain rule. Okay, so for chain rule, if you have if you're trying to diff the function of u, but you diff this by x, okay? So you diff y, and y is a function of u, but u is a function of x, okay? You need to do the chain rule. For example, if you try to diff this polynomial, okay, it's quite hard for you to expand this polynomial, okay? It takes times, okay, and especially if you have the power of 5, okay, it will be very tired to like expand this polynomial. So to give you some more time, okay, I will just try to consider this y as u cubed, okay? So and if I do dy by dx, okay, we need to subject our differentiation into chain rule. So dy by dx, we can write down as the dy by du times du by dx. So dy by du, okay, is diff of u cubed, okay, because y is actually u cubed, or u to the 3, and then du by dx is the diff of 2x plus 3, okay? So because this one is u, this one is u, okay? So so when we work on this thing, okay, so for the first differentiation, I will come up with 3u squared, and then we times by diff of 2x plus 3, so that we have 2, okay? So that I have dy by dx as 6u squared, but actually you have specified you have given u as 2x plus 3, okay? So I bring back 2x plus 3 into the same equation, so that you can get back 6 times 2x plus 3, okay? But to do this in short, to save you, to buy you some more time, so the technique, okay, is for the chain rule, right? You consider doing these two things, okay? So the first thing is to diff, I would say, is to diff outside, okay? So diff outside, and the next step is to times by the diff inside, okay? Outside and inside. So what is actually outside and inside, okay? So outside, okay, so if I do dy by dx for this function, okay, so diff outside, what I do is I just do 5. I just bring 5 to the front, just like you do the same old differentiation. So it's 5 times by the whole thing over here, okay? And the power is, of course, reduced to 4, okay, 5 to 4. Then you times this by differentiation inside, so diff inside, okay? So I would times this by d by dx of x squared minus 2x and plus 2. So this is the diff inside stuff, okay? So we're working out this diff inside stuff. So we have 5 times by the whole thing here. Okay, and then times by 2x minus 2, okay? And this is your answer for the number 2, okay? And then again for the chain rule, so when you come with this function, okay, this function is quite hard, so let's have a try. So what I do is I will rewrite this function in terms of, so if you have 1 and over 3x minus 1 over 2, you can swap the denominator into the denominator by 3x squared minus 1, and the power become minus 2, right? So, so I start with dy by dx, and you diff outside first. Diff outside will give us -2, and times by the whole thing, the whole bracket, and the power become -3. And then times by the diff inside. So diff inside is d by dx, or diff of 3x squared minus 1. So this is like the inside. Okay. And the results from differentiation inside, okay, this differentiation inside would be in terms of 6x. Yeah, 6x from diff inside. And from the normal differentiation, it is 2 times by -2, and then to be divided by 3x squared minus 1 and power by 3. Okay, so that the dy by dx of this function will be -12x over 3x squared minus 1 to the cube. So this is the application of chain rule. And then integration. So integration is actually the counterpart of the differentiation. Okay. For example, if I have differentiation of like x to the 3. Okay. So what I get is I get 3x squared, right? But if I do the integration of 3x squared dx like this, what we do is I start with 3x squared, but I then increase the number of power by 1, so it's 2 plus 1, and I divide the number 2 plus 1 over here. So that I'm doing according to this formula. Okay. So that here I add this up with unknown constant c. Okay, and what we should get back is 3 can be cancelled, and we should get the x to the 3 back with some unknown constant. Okay, so some more examples. Okay, so I do integration of like, let's say 2x to the 5, okay, dx. Okay, and here I will get 2x to the 6 and divided by 6 and plus the constant. So that I get 1/3 of x to the 6 plus constant. And then if you integrate 1, okay, you always get x. Okay, because we integrate 1 dx, okay, is integrate x to the 0 dx. So that would be x to the 0 plus 1 or 1 and divided by 1 and plus unknown constant. So that you get x plus c for certain. Okay, and also the same thing, if you have a constant, you just pull it out. Constant is no problem, and you can also distribute the integration into 2 functions. Okay, so some more examples. Okay, integrate x dx here. Here I would just come up with integrating x to the 1 dx, so which is x to the 2 and divided by 2 and plus unknown constants. Okay, then if I try for this polynomial, okay, so this would be integrate x squared dx plus 2 times integrate x, because we can bring the constant out, so 2 times integrate x dx, and then -3 and times integrate 1 dx. Okay, so that here I get x cubed over 3 and plus 2x, so 1 plus 1 is 2, and over 2, so this one can be cancelled, and then -3 integrate x, integrate dx, or integrate 1 dx will give you x, and plus an unknown constant. And here's your answer. Okay. Then if I come up with something like this, okay, I can then rewrite the function or the integrand as -2 and times by x to the -3. Okay, it's easier this way to do the integration. So that -2, I bring it outside, and then -3, we add up 1 to the power. Okay, so that these need to be divided by -2. Okay, and then we can cancel -2 and -2. Okay, and plus an unknown constant. Yeah, and so that what we get from here is x minus x to the -2 and plus c, or it is 1 over x squared plus c. Okay, so that is the integral. So to solve for the unknown constant c, so if we want to know, we want to put some initial conditions. Okay, so let's try to do this integration together again. So y is integrate of 5 minus 2x dx. Okay, so we work on the first term. So integrate 5 will be 5x, and integrate minus 2x will be minus 2x squared over 2, and 2 get cancelled. Okay, and plus an unknown constant. So we have something like minus x squared plus 5x plus c for this integral, but we actually don't know the value of c, right? But in order to know this, we should apply this initial condition. Okay, so if they say that y equals to 1 at x equal to 0, okay, this means that y at x equal to 0, or y0 is actually equals to 1, right? So when I have y as a function of x as minus x squared plus 5x plus c, and then I try to apply y0, okay, equal to 1 into this equation, so that I would substitute 0. I substitute 0 into all the terms. Okay, so then I have minus 6 minus 0 squared plus 5 times 0, which should actually be 0, and then plus c, right? So here I can get c equal to 1. So when we get c equal to 1, the unknown constant now is become known already, right? So that's the last value. Okay, the last thing that we get for y is minus x squared plus 5x and then plus 1. Okay, because c is equal to 1, and that's be your answer, right? And the other type of the integral that we would come across in many of the examples is the definite integral. Okay, it is the integral with lower bound and the upper bound. Okay, so when we do the integral, okay, it is that after we perform the integral, okay, what we do is to substitute the lower bound and upper bound into the equation, so that, for example, if I integrate fx and we have gx plus c, and c is the unknown constant, okay, and we then substitute the lower and upper bound into the gx, okay, so it is going to be a substitution of the upper bound, or b, okay, and minus the substitution of the lower bound, okay, and then we should get the final answer by GB minus GA. Okay, so let's have a look at the examples. Okay, it's easier for you to look at the example for this. So we have, so here we call this integration is as the integrate of x squared from x equals to 1 to x equals to 2. And x equals to 2 is set as the upper bound. And x equals to 1 is set as the lower bound, okay? Right? So I would integrate this function normally as x squared dx, and I get x cubed over 3. And with the upper bound and the lower bound, 2 and 1. Yeah, 2 is upper, 1 is lower. Okay. Then what I do is I just substitute 2 into the integrated function. So that I have 2 power 3 over 3. Then minus the substitution of the lower bound. Okay, so that's I have 1 cube divided by 3, right? So that I have 8 third minus 1 third. So the answer is the integration from x squared dx from 1 to 2 is 7 over 3, or 7 third. So you should get the result as the number for this. Okay, so let's practice for more examples. Okay, so we're trying the one that is not so straightforward like this. Okay, so for this integral, I would rewrite the integral. So I put upper and lower limit the same, but I rewrite square root y as 1 over square root y as y to the minus 1 over 2 dy, right? Then we integrate this function. So y to the minus 1 over 2 will be added by 1 for the power. And that would give you 1/2, right? And we bring 1/2 to divide. Then we still need to consider the lower and the upper limit, 4 and 9, okay? And okay, I just make this to look a little bit more beautiful. So I bring 1/2 up there to be 2, and times by the square root of y, because y minus y to the minus half plus 1 is y to the half, and y to the half is square root of y, right? And then we divide this by 9 and 4. Okay, so it's 2 times by the square root of 9 and minus 2 times by the square root of 4. Okay, so that would be 6 minus 4, yeah, 6 minus 4, and our answer is 2. So that this integration, yeah, the answer of this integration, remarkably, 2.